What's up, Warhawks? Going to try to do a quick lesson here on 5-4. We have these things that are called 45, 45, 90 triangles. They're a special type of triangle. And the reason is they're quick hitters. They're stuff that you can, as soon as you see it's a 45, 45, 90 triangle, this pattern always happens. So we're going to kind of talk about that pattern and then use it in a bunch of different examples. Hopefully this won't take too long. So here we go. We got 45, 45, 90 triangle. Well, you just talked about the angle and the sides, how if you have the smallest angle goes to the smallest sides. Well, just like that, if you have the same angle twice, you know that automatically the side opposite, those two are going to be congruent. So that's why those two marks are there. So in this, we have two sides. It's a 45, 45, 90 is always going to be an isosceles triangle. Always these two sides are going to be congruent to each other. And then this, of course, is a right triangle. So a squared plus b squared is going to equal c squared. But this a and this b is going to be the same value. So actually we're going to have something twice that value in squared. So either a or b, it doesn't matter, is going to equal c squared. So we're going to talk about what that happens in that pattern. So here it is. You know that the two values that are across from the 45s are going to be the same value. So that's why they're represented as x. It's going to be some number, 10, 5. It can even be a nasty number, which we're going to get into here in some of the examples, like 5 square roots of 7 or 5 square roots of 2 or something like that. Now the weird one is this one over here. The one that's always across from the 90 degree is going to be this number right here, or this one, because they're both the same, and you're going to multiply it times the square root of 2. So if this is 7, this over here is going to be 7 square roots of 2. That doesn't seem too hard, doesn't seem too difficult. It can get a little tricky, but it has to do with the algebra behind this stuff, not to do with really the geometry. Now on the contrary, think about this for me. If I give you that this is 7 square roots of 2, and you want to go backwards, if you go forward this way, from here, if you go from here to here, you multiply. Well, what if you go backwards? Hopefully you're saying in your head, you would then have to divide. So depending on which way you're running this, you're going to sometimes multiply by the square root of 2, or you're going to have to divide by the square root of 2. So if you are given the one with the 90 degree, you're going to be dividing. If you're given the one with the 45 degree, to get to the 91, you're going to have to multiply. And again, that's always across. It's always the one that's across that you're talking about that goes with it. So here we go. Let's get into some examples. So if I've given you this, and I want to find this length right here, and I want to find this length right here, hopefully you realize since this is across, that's across from the 45, and that's across from the 45, these two guys are going to be the same. So if that's 5, this is 5. And then we talked about all you have to do is, since I'm going this way, I have to multiply, and by the square root of 2, well, 5 times the square root of 2 is 5 square roots of 2. That's it. Nothing too tricky about that. Next one. This one's a little bit trickier because they did give me the one across from the 90. So I'm actually going to be going backwards, which I did it in green, so I'm trying to keep that for you. And that's going to be dividing by the square root of 2 because I'm kind of going backwards. And also this one I would be dividing by the square root of 2. But really, once I figure out what this value is, I know this has to be the same. So if I take this 3 square roots of 2, and I divide it by the square root of 2, this one is one of the simpler ones because the square roots of 2 cancel out, and I'm left with just a 3. And if this is 3, this would also have to be 3, which makes sense because if I go forwards and I multiply by the square root of 2, 3 square roots of 2 is what I end up with. So it all kind of checks out for me. All right, moving on to this one. This one they gave me, this is the one across from the 45. So this one across from the 45, this is 5 square roots of 2. This is going to be 5 square roots of 2. Now, if this one is the 90, then I have to go across from the 90. Then I have to take this and multiply it by the square root of 2. Oops. Should be 23. Right, sorry. multiply it by the square root of 2. So let's go see what that does over here. 5 square roots of 2, and I'm timesing it by the square root of 2. Well, hopefully you see this is multiplication. And right here, I'm multiplying the same thing times itself. So technically, I can write that as 5 square roots of 2 squared. Just like if I had x times x, that becomes x squared. I'm multiplying the same thing by itself. Well, what happens here is you have the square root and the square. Hopefully you realize they're inverses. They cancel out, and there's still a multiplication sign here. So 5 times 2 is 10. So my final answer is 10, and yes, it needs to be like that. That's kind of fully reduced and simplified. All right, next one, we get into some definite algebra skills that we need to review on. Hopefully we'll get some more practice on this in class when we do this, the skills practice. Please pay attention to this one. Pay attention to these if you get them in class. On the EOC, they probably will give you something like this. All right, so again, this is my green one because it's the one that's across from the 90. Remember, it's always across from it. And I'm going to be working backwards, so I'm not multiplying. I'm dividing by the square root of 2. And then whatever this value is, this is going to be the same because they're both the 45s. So I take that over here and I go 10 divided by the square root of 2. On first look, that seems like that's the answer, and it's easy. Yes, that is the geometry part. Now the algebra part comes in. I am not allowed to keep the square root of 2 in the denominator. It's a rule, not allowed to keep it there, so I got to figure a way to get rid of it. Well, hopefully in that last problem we remember that if you multiply the square root of 2 by itself, then that canceled out the square roots, which is what's my problem. That's my problem in the denominator. I'm not allowed to have that square root there. So in fractions, if you multiply the bottom, you must multiply the top by the same thing. So if I take this and I multiply it by the square root of 2, and I multiply the top by the square root of 2, I'm really timesing by the number 1, which won't change my value of this, but will change the way things look. I've used that in my classroom quite a bit, so hopefully they understand that. The square root of 2, I'll end up with 10 square roots of 2 on top over the square root of 2, and hopefully you see that it can be squared. Well, what happens when you have the square root and the square? They cancel each other out, and I'm left with 10 square roots of 2 over 2. Another thing is coming into play here. I have fractions, and I have a 2 and I have a 10. They have something in common. 2 can go into both of them. So I cancel the 2 out and I get 5. I cancel the 2 and I get 1. And 5 square roots of 2 over 1 is just 5 square roots of 2. And that would be my answer that I would put here, 5 square roots of 2. And this would also be 5 square roots of 2. So that's the kind of tricky one. They can do other numbers up there, so sometimes it will cancel out, sometimes it won't. If you have questions, make sure you try those and get some answers on that, reducing and getting rid of that. You're not allowed to leave the square root in the denominator. That's in any math class. All right, so a square has a perimeter of 32 inches. There's not a picture drawn, so good idea. Geometry, draw a picture. Square, 32, 32. And they said, how long is that diagonal? Well, if I draw on the diagonal, hopefully you realize you've got a triangle, and if these two sides are going to be congruent, that has to mean that this is a 45, 45, and then this is a 90. We also know that that's a 90 because it's a square, and in the corner of the square that has to be a 90-degree angle. This is also split in half, which makes it 45. They want the length of this. Well, they gave me the length of the 45s, so I'm going forwards on this. So we use red for that. We're going to be going forward, which means we multiply by the square root of 2, and my answer would be 32 square roots of 2. Now, if they ask me for the exact answer, that would be my exact answer. If they asked me to round it, I would go 32, and I hit times, and then in my calculator, I hit square root of 2, and then I get an approximation, blah, 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 whatever that is. Okay? All right, last one, and we're finished up. All right, Sam's square bedroom, so we have another square, has a diagonal of 9 square roots of 2. What is the length? Well, if I'm going to do this, I got to go ahead and say, well, which way am I working? Well, since this is my 90, and that's across, I'm working back towards my, which should be in green, I'm working back towards my 45s. So I know that I'm going to divide by the square root of 2. And when I do that, I take 9 square root of 2, divide by the square root of 2. See that the square root of 2's, that's really like 1 that cancel out. I'm left with 9. I know that his bedroom is a 9 by 9. Alright, hope you have a good weekend. Get ready, we got a test coming up here very soon. We got 5-5, which is another special triangle, which we'll get to. It's a little trickier, but not too much, same kind of idea. We'll practice this on Monday, get some notes, and then get to that test. Have a great weekend, guys. See you.